Hi guys, my name is John Joshua from RK08 and I'm from Group 18 and our group is Hafizi and Muhammad Shukru Irfan and our group title is Automated Transport Farming Sprayer with Tower Use. Today we like to present our conceptual design.
Hi, my name is Muhammad bin Azan. Okay, today I would like to talk about chapter 1, which is introduction, and it's content about project purpose, objective, and scope. Okay, next, first about project purpose. Agriculture sector play an important role on develop a stable economy because it produces agriculture product for export sale. In this pandemic situation now, many farmers face various problems, and farmers face a problem on increasing the production of their farm due to a low efficiency and old transport mechanic. Thus, it is important for a new technology to be developed to ease the plantation activity, such as carry the plantation equipment, faster the time take to farmer to crop the plantation area, and maybe make it easy for farmer to transport from one place to another place. Hence, the technology purpose must be affordable to the smallholder farmer, require less skill, and easy to operate, also highly efficient and able to cover wide area of plantation. To solve this problem, we come up with four-wheel custom transporter powered by the two-stroke engine, detachable multipurpose stowing rig to carry plantation equipment and any object, attached with adjustable spray system to crop the plantation area and have an automatic spray using ultrasonic sensor. Okay, next, about our objective for this project, which is our objective is to design a smart transporter with stowing rigs that function to automatically spray the fertilizer or pesticide liquid and efficiently crop the plantation area which cover wider area. And second is to design IR 4.0 system for a sprayer to automatically sense the plantation with ultrasonic sensor that will trigger the sensor to activate the pump sprayer. Okay, lastly for the chapter 1 is about the scope of our project. So there are 8 points to talk. So I will mention the highlighted one, which is first, this product is focused on agriculture sector. So the customer are smallholder farmer, and our scope is for vegetable farms or any suitable, and the price is reasonable, around 2000 RM 2000 to 4000 ringgit, and it's a quite light, can save power efficiently, and product completely conservative and has a safety feature, and the weight is able to withstand heavy weight up to 100 kg, and the product is available in e-commerce website so that the market is huge and there is a lot of potential of it easily to reach by many people, and the market potential for this product is estimated to be 100 units per year.
Okay, Assalamualaikum and hi. My name is Muhammad Afiq Hafizi bin Norazmi and I will continue the presentation for our integrated design project that was chapter 2, need analysis. Before we start the need analysis, we do some benchmarking for the several products in a market that was similar with our product. Okay, the research for our benchmarking are drone sprayer, UAV and also backpack knapsack sprayer that was used in agriculture industry. We also do some comparison between these two products starting with their price, tank capacity, time taken for 1 hectare and also focus the value coefficient of variance and penetration ratio. We can see that backpack knapsack sprayer is higher penetration ratio since this method spray beside the plant, so that it's more efficient for agriculture. Same with our product that not only efficient but it can also cover more wider area. Okay, the next part is a design analysis. Firstly, we create the questionnaire by using the Google form, then we distribute the link through the online social media. This survey collected to 50 respondents, which is consists people who work in a small farm or people work in agriculture industry. This survey was divided to a three part, which is demographic profile, general overview, and customer expectation. Okay, the first part in our survey is about demographic profiles such as a gender, age, and also race of our respondent. Okay, the next part is about general overview for the method farmers use for fertilizer. In this part, we ask about experience of respondent in agriculture industry, their method used for fertilizer in their farm, and also effect increase the number of spray hole at a nozzle that can increase cover wider area. We can see that almost 50% of respondents are used knapsack sprayer for fertilizers process that is a slow method and needs more worker for a big field. Okay, lastly, we also want to know the customer expectation to our product, such as the fertilizer process speed for our machine. Machine should be reduce the wastegate and also the machine should be simple to operate.
Okay, next I would like to talk about the design specification in chapter 3. And in this part, I will explain about the house of quality and also the product design specification. Okay, HRQ basically is the one of the QFD product planning stages, which is used to identify the relationship between a customer requirement and demand as well as a product capabilities. The relationship matrix shows the relationship between a customer requirement and engineering characteristic. Is it in the center of the HRQ, and the weight vector and ranking in the relationship matrix are used to compute the ranking order state at the bottom of HRQ. From the HRQ diagram, our product has been ranked to the three important engineering characteristics, which is safety factor, lifespan, maintenance, and material properties. The improvement for the safety factor is in terms of easy for maintenance, transportable, easy to operate, and durable. For a lifespan, the improvement is quite similar to a safety factor, but exclude the transportable. Lastly, maintenance and material properties share the same rank, but we need to choose either one. It's more important to be used. As a conclusion, HRQ play the important role for us to develop a new product, which the customer requirement and the engineering characteristics are the two factors to consider. Lastly, about product design specification, you can see here the product design specification (PDS) is a structured description of the design, problem, goal, function, characteristic, and other information. PDS is a crucial initial stage in any design process, since a good design will define the product that satisfies all project objectives. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good day to all my lecturers and the coordinator of this subject. My name is Muhammad Syukur Irfan bin Abdullah from RK08. I am from group 18. So today I would like to present about our concept generation of this project. Concept generation in this chapter will be generated one by one as we had gathered all the customer needs and target market of product specification. We will generate all the ideas through a few stages of functional and physical decomposition. Then the process continued with morphological chart, context diagram, calculation of the physics design, and design parameters and constraints before we come up with the final design of the product. Functional decomposition. Functional decomposition is a method to help us to design in the proper way. It is a common strategy used for solving any complex task or describing any complex system. This method helps engineers to understand the product well by creating physical decomposition first and then followed by the flow types. Physical decomposition is the process of breaking product into its subsidiary sub-assemblies and components while properly defining the elements that work together to form the product's behaviors. The figure shows the physical decomposition of automated transport farming with towing rigs. Next, functional basis. All technical systems are represented as transducers in the functional basis, interacting with the world around them by changing energy, materials, and signal flows. The table below shows the standard flow classes and member flow types of functional basis. For the system design, the main function of the design is to spray the fertilizer to the crops in certain area. In general, the system started from human energy, mechanical energy, and the output is kinetic energy and pump energy. For the material output and input of fertilizer, in this device, it needs to have mechanical energy, electric energy, and also electronic to complete the process of the design. Next, we have function block. Function blocks are filled in the blocks and arranged in the sequences to analyze the more detailed description of the function of the device. The arrangement of the function depicts the precedence required by the main function. The figure shows the function blocks of automatic transport with smart towing rigs. Function structure is a block diagram that depicting a flow of energy, materials, and signal as labeled arrows taking place between the function block. Figure shows the flow byte for achieving the function. From the initial state, the engine of byte is turned on. Then we actuate speed control to run the engine to give the rotation of the wheel. We start the generator of water pump system. When we go on through the farm, the crop is sent by a sensor which is placed at the sprayer. It will produce the electrical signal and transfer to the sensor. The sensor transfers the data to the sprayer and spray the fertilizer to the crops. A morphological chart is a visual representation of the required product functionality that allows user to experiment with different methods and combinations to achieve the goal. The chart makes it possible to define these solutions and give a framework for considering other combinations. This allows for the early consideration of the product architecture through the generation and consideration of possible combinations. Table show the best solution concept generates for each sub-problems. All the sub-functions ideas are generated and combined into an overall solution to get the best solution. Last but not least, for the conceptual design, we have sketched 4 different types of design concept. Concept 1 and the component used are shown in the figure, followed by concept 2, concept 3, and concept 4. In the next chapter, we will discuss the final design selected for our product. So that's all from me. Thank you.
Hi guys, my name is Yong Jiashen from RK0A and I'm from Group 18. Today I would like to present my topic based on chapter 5, Conceptual Design. So the first one is there are 5 criteria that I think it is based on the bike with a sprayer towing which are the cost, self-part assembly, durability, size of materials, and the size of nozzle. So the next is this table shows the criteria comparisons matrix. So these are the values that shows for the cost, self-part assembly, durability, size of materials, and also the size of nozzles. And the next one is the normalized criteria comparisons matrix. So therefore, the next tables and the following is show that we have used the AHP to do the criteria for these 5 factors, which to show which the values which are higher in the concept. So the first one is the cost, and the second one is the self-assembly. The third one is the durability, and the fourth one is the type of material, and the fifth one is the size of nozzle. So to conclude, for the final decisions matrix, the values for these criteria have shown that the concept 4 has the highest value. So for the weak decision matrix, weak decision matrix is a technique for testing competing concept by classifying design criteria with weighting variables and evaluating the degrees to which each concept fulfill the criteria. So the next is it shows how we do the scales for our design. So this is the table that we do the weak decision matrix, and this shows that the concept 4 has the highest value. So the next one is the part concept selection chart. So we also see that there are 2 tables. In the table 1, show that the third concept and the fourth concept almost have the same score, but for the part selection chart 2, concept 4 has the highest value. So due to the greatest value received from the part chart selections, the concept design 4 is chosen as our final project. So the sketch may be seen in figure 5.1. So it has the highest value in terms of time taken, manufacturing cost, safety factor, lifespan, multifunction, durability, weight, material properties, wide area cover, and maintenance. Thank you.